Okay, so in this video, I'm going to do pages 77 and 78, which are angles formed by intersections. 77 is inside a circle, 78 is outside a circle. And so I'm only going to do some of these examples just for the sake of time because this is the last week. So I will skip about half of this just so that you have enough that you need for your assignment. So angles inside the circle. So if I have two chords that intersect inside a circle, so our chords are A, C, and B, D, they intersect inside the circle there. Then the measure of each angle, so angle 1, angle 2, they're vertical to the other two angles that aren't labeled, so they're the 4 angles that only have 2 measures within that circle. It's half the sum of the measures of the arcs intercepted by the angle. So I guess that might be orange, not red, but I used a red marker to outline the formula. So if I look at the circle, so this red arc AB and this red arc DC, those are used to find the measure of angle 1. So the measure of angle 1 is the sum of those 2 arc measures divided by 2. It's half of that sum. If I want to find angle 2, it's the sum of the arc measures that are opposite those angles. So arc AD plus arc BC divided by 2 is how I would find the measure of angle 2. And so in general, I just think about it as the arcs that are closest or across from those 2 angles. And so I think about it generally as it's the sum of 2 arcs divided by 2. Okay, so in these problems, we're going to be using that formula the entire time to solve for missing angles and missing arcs. So we're going to skip around again. So I'm only going to do some of these. I'm going to start with the first one because it's basic. So angle 1, the 2 arcs that are, the arc that's opposite angle 1 is the 40-degree arc. The other arc is marked as well. So based on our formula, the measure of angle 1 is equal to the sum of those 2 divided by 2. So that means that I'm going to take 40 and add 30 so that I have 70 divided by 2. So that means that the measure of angle 1 is 35 degrees. Next, I'm going to do C. So for C, what's different is that I want to find angle 1, but I don't know anything about the arcs that I need for angle 1. So I would need those 2 arcs. I can't find them from here. So what I want to do then is I want to just find angle 2. So I'm going to plug in angle 2 there. So notice that the measure of angle 1 is a straight line with 2. So that would mean that I can do 180 minus the measure of angle 2. And that will give me the answer for the problem to find measure of angle 1. Because with measure of angle 2, I can use the formula. I can do the sum of the 2 arcs that I know divided by 2. So that means that I can add 78 and 50. And so that means that I have 128 divided by 2, which means that the measure of angle 2 is 64 degrees. So that means that if I subtract 64 degrees from 180, so 180 minus 64, the angle that I want is 116 degrees. Okay, so if I don't have the right arcs, I can always find the other angle and then just subtract it from 180 to find the answer that I'm looking for. We're going to do F next, which is similar. So again, I want to find angle 1, but I don't know the arcs across from angle 1. And so I want to find angle 2 first instead. So looking at this then, the measure of angle 2 is going to be half the sum of the arcs that are labeled. So those arcs are 41 and 53. So that means that we have a sum of 94 divided by 2. And so that means that the measure of angle 2 must be, I almost wrote 97, must be 47. Wow, making a mess here. 47. And again, I want to find angle 1, not angle 2. So I have to do the measure of angle 1 is 180 minus that 47. And so that means that our answer is 133. Okay, so I'm using this formula for every single problem on this page, and you'll use this formula for any problems on your assignment that have the crossing inside, so it looks like an X inside the circle. We'll see something different on the next page. So then I'm just going to do example 2. We're going to skip example 3 completely and then move on to the next page and do a different formula. So for this problem, so for A, I have X is an arc. So it's different, but I still have 2 arcs that are across from each other. And so if I knew one of these 2 angles here, then I could use the formula, right? So the measure of one of those 2 angles is equal to the sum of the 2 arcs divided by 2. So if I know one of those 2 angles, then I can use the formula that we've been using. But I need to find one of those angles first. So just like we did in the last problem, at the very end, we're going to start with that. So if I want to find this guy, or that guy for that matter, I would do 180 minus 129. So those 2 have to be supplementary. So that means that this angle here is 51 degrees. Or this angle here is 51 degrees, right? And this one has to be 129 as well because they're vertical angles. So as long as I know one of these 2 51s, then I can set up the problem. So if I have that, I know that 51 is equal to X plus 35, I can use algebra to solve for X. Okay, so each time I'm doing this, if my X is inside the fraction, then I'm going to follow the same 2 steps, which are I'm going to have to multiply by 2 because I need to get the X by itself, and it's all currently being divided by 2. So if I take and multiply both sides of the equation by 2, 2 times 51 is going to give us 102. And the 2 here was the whole point was to cancel that out. So I just have X plus 35. Okay, so I had to find that angle that was inside the X with where I knew the 2 arcs. And then I plugged it into our sum of the arcs divided by 2 equals the angle. And so now I just have to subtract 35, and that will give us the value for X. So if we subtract 35 from both sides, X is 67. And I don't have to put the degrees because there's already a degree symbol there. So keep that in mind as we do these. With these, I had just the number of the angle, so that's why I put the degree symbol. This one, it's already there, so I technically don't need to write it. We're going to do B. It's the same exact process. It's just different values, and it's in a different place. But notice that, again, I know these 2 arcs, so I need to figure out what this angle is or what this angle is. And to do that, I just have to do 180 minus the 137 that was given as the other angle, because that these 2 form a straight line, so they're supplementary. So that means that these angles are 43 degrees. So that means that 43 degrees, my angle, must be equal to the sum of the arcs divided by 2. So the 2 arcs are 25 and X. I did the degree for the first one, so I need to do them. Okay, so same process. I have to get rid of that 2 because I don't want it to be in a fraction. So if I'm going to multiply both sides by 2, that's going to give us 86 is equal to 25 plus x. And then to get x by itself, we want to subtract the 25. So that gives us that x must be 61. Okay, so that is when I have two lines that are intersecting inside the circle. We're going to look at page 78 next, and that's going to be where I have two lines intersecting outside the circle. So if two secants, two tangents, or a tangent and a secant, so remember that a secant is a line that goes through the circle, whereas these were chords. Chords stop at the end of the circle. A secant goes through the circle twice. So this one is two secants, and they intersect outside the circle, so they're intersecting out here at this point. Then the measure of each angle is the difference, is half the difference of the measures of the intercepted arc. So almost the same equation, we're just subtracting instead of adding. Because we're subtracting, it's important that we use the big arc first. So this should always give us a positive number. If for some reason we mess up and we do small minus big, we'll get a negative, but the number's still correct. So you just need to know that it has to be the positive answer. So I would take arc xy, the measure of arc xy, and subtract the measure of arc wz, and that would give us this formula. Again, generically, we can think about it as the big arc minus the small arc divided by 2. If I have two tangents, so two lines that only intersect the circle once, it's the same idea. So we're doing the big arc, which is the arc from P through Q to R, minus the arc just from P to R, the shortest distance. So the large arc minus the small arc divided by 2. And then finally, if I can have one of each, so if I have a tangent and a secant, I'm still using the big arc minus the small arc. So the big arc here is BC minus the smaller arc AC divided by 2. Okay, so instead of adding for these problems, we're subtracting. Know that these will be mixed up on your worksheet, so you're looking at which diagram does it look like in order to figure out which formula you're using. So again, we will just do some of the examples. We're just going to do example 1, example 2, example 4, and example 5 for this, just so that you can be prepared for the worksheet, not the more complicated problems. Okay, so for this first one, we have two secants, and it looks like we have what we need. And so if I'm looking at this diagram, this is the big arc, and 34 then is the small arc. I'm just going to write SM. So what that means is that to find the measure of angle 1, we're going to do big minus small divided by 2. So 108 minus 34 divided by 2. So 108 minus 34 gives us 74. If we divide that by 2, that gives us an angle of 37 degrees. So measure of angle 1 is 37 degrees. For B, we know the big arc. So the big arc here, so measure of angle 1 is going to be the big arc minus the small arc divided by 2. So looking at this diagram, the big arc inside here is 119 degrees. We have a problem though. We don't know what the small arc is. We do, however, know what the rest of the circle's arc measures. And so what that means is that in order to find the small arc, we're going to have to do 360 because a full circle minus the 174 and minus the 119. Okay, so if I subtract both of those numbers from 360, that gives us 67 degrees for the small arc. So we're going to do 119 minus 67, which is 52 divided by 2. So that means that this is a 26-degree angle for the measure of angle 1. Okay. So we're going to look at example 2. In example 2, they tell us that AB is 50 degrees. So if I look at AB, that's the small arc on this diagram. So in order to find the measure of angle D, I need to know the large arc. So the small arc is 50. So I'm going to subtract 50 from here. The diameter gives us a clue as to what the this half of the circle is. So if I think about this, I need from here to here, right? So if I know that this is 50 degrees, then that means that what's left is actually the rest of the circle, because this is a tangent. So if I look at this, I need to know what all of that is. And so to do that, I just need to do 360 degrees minus that 50 degrees. So that means that the large arc, so our big arc, is 310 degrees. Okay, so the rest of that circle must be 310 degrees because of those are two tangents, and it's the whole rest minus the 50. So 310 minus 50 gives us 260. And if we divide that by 2, we get 130 degrees. So that means that measure of angle D is 130 degrees. Okay, so in B, we're going to find the measure of arc AB. Since it's an arc, I'm going to call that X. So if I look at the diagram, that's actually the big arc. I'm going to call the big arc X because that's what we're looking for. The angle is 10, and the small arc is 20. So the big arc is what we're looking for. So in our formula, we take the angle, which is 10. We set that equal to big minus small divided by 2. So since big is our unknown, we have X minus 20 divided by 2. So this ends up very similar to the problems that we did when the arc was unknown, in the sense that our first step is going to be to multiply by 2 no matter what here. So I need to multiply both sides by 2 to get rid of the fraction. That gives me that 20 is equal to X minus 20. And so if I add 20 to both sides, that tells us that X is 40. And so that is the measure of arc AB. So the measure of arc AB is 40 degrees. We're going to skip example 3. It's just a little more complicated than you'll have to do for the assignment. And then look at example 4 and 5, and then that will conclude this lesson. So for this one, we have variables going on. So we're still going to be using the formula. So remember, the angle is equal to the difference of the big arc minus the small arc divided by 2. Because we have expressions, one thing to remember is that we're probably going to have to put the second one in parentheses and use that to simplify. Technically, we could put the first one in parentheses too, but since there's nothing in front, that's kind of redundant. So the angle is 39 degrees. So 39 is equal to the big arc. So the big arc is this one, 17x plus 6, minus the small arc, which is 7x minus 2. The reason that we need to do the parentheses is because I'm subtracting both of these pieces, so their signs are going to change. So this is going to become minus 7x plus 2, and the whole rest of the equation stays the same. So I still have 39 equals 17x plus 6 divided by 2. So then if I look at this, I need to combine like terms. So if I bring down the 39, and it's still going to be over 2, I have 17 minus 7, so that's 10x. And then I have 6 plus 2, so that's plus 8. So what I can do with this one that I couldn't do before, so I multiplied by 2 over here because of this x. I can't divide x by 2. I'd still have a fraction. For this one, though, I can't divide both of these by 2. So what I can do instead of having to multiply both sides by 2 is I can divide. So if I divide 10 by 2, that's going to give me 5, but I have to also divide the 8 by 2. So that's going to give me 5x plus 4. And then I can subtract 4 from both sides, which gives me that 5x is equal to 35. And so then dividing by 5 gives us a value of 7 for x. Then for B, it's a similar problem. We have tangents instead of secants, but we're still using that same formula. So remember that the angle, so 61 degrees, is equal to the difference of the big arc, which is 10x plus 1, minus the small arc, which is 5x minus 1, divided by 2. So if we simplify this, we've got that 61 is equal to, and I'm going to kind of distribute up here. So this would be negative 5x plus 1 once I distribute and combine just to save myself some space. So 10 minus 5 is 5x, and then 1 plus 1 is 2. So notice that dividing both of these by 2 is not an option because 5 is not divisible by 2. So that means that we're going to do this the old way and just multiply both sides by 2 to get x by itself. So 2 times 61 is going to give us 122. This to the point was to cancel, so that's 5x plus 2. We're going to then subtract 2 from both sides. So 5x is equal to 120. And then dividing both sides by 5 gives us that x is 24. And the last one that we're going to do for this lesson is example 5. And the reason I want to do this is because it's a mixture of the two. So angle 1 is inside the circle, and angle 2 is outside the circle. So to find the measure of angle 1, we're using the inside formula, which is the sum formula. To find the measure of angle 2, we're using the outside formula, which was on this lesson, the subtraction formula. So if I'm looking at the diagram to find measure of angle 1, I'm going to add the two angles together that are across from 1. So angle 1 is here, across from it are the 70 and the 50. So if I do 70 degrees plus 50 degrees that gives me 120 degrees. Divided that by 2 is 60 degrees. So the measure of angle 1 is 60 degrees. If I look at where angle 2 is, and I'm just going to kind of highlight that one with orange so that we can see the angle and the 2 arcs that we need. That 70 is a part of this problem as well. So that 70 is actually the big arc. So we're going to do 70 minus the small arc, which is the 26 here. So 70 minus 26 gives us 44. And if we divide 44 by 2, that means that angle 2 is 22 degrees. So those are the two concepts for angles when I have segments intersecting or intersecting outside or inside a circle. So again, if it's outside, we're doing half the difference of the arcs, and if it's intersecting inside, we're doing half the sum of the arcs, but structurally they're very similar problems.